The graphs of linear functions are straight lines, right? And they have a constant rate of change, like walking. Let's brainstorm real-world situations that could also be represented with linear functions. We looked at walking. This is also about walking. How about those of you that got paid this weekend? Did you have an hourly wage? So if you worked 20 hours times whatever you make per hour, you should be able to calculate what your paycheck was. That's separate from tips. That's separate from overtime. But if you have your hourly wage, then you should know what you get paid, right? Something else that's linear. What else could be linear? Can you think of anything else? How about just the number of inches in a mile? We did that last week, right? If my miles goes up, I can calculate how many inches would be in that mile. So unit conversion is linear. How many cups in a gallon, right? Something else that's linear that you might not think about, but if you are a certain height as a person, scientifically, your wingspan is proportional to your height. Anyone remember Michael Phelps, the Olympian from like 4 years ago? He won a ton of gold medals. Why was he really good at swimming? One reason was his wingspan. His arms were incredibly long because he was so tall. So his arms through the water have a huge wingspan. So you have an advantage as a swimmer. If you're really tall, you got really long arms, right? So there's a relationship linearly between shorter people have shorter wingspan, taller people have taller wingspan. That's a linear relationship. Okay, proportionally. So proportionally, this is real world data. If it should be pretty proportional. It might not be exactly equal to your height, but taller people will have a longer wingspan, shorter people. But you're right, you might have slightly longer or shorter arms. Good point. That's experimental data, just like our walking and our bouncing balls. So here we go. This group of people is walking in the Jimmy Fund walk. They raise money for cancer every year, and they go 26.2 miles. So the same as the Boston Marathon, they walk that route instead to raise money. I don't know what this little IN is for. That shouldn't be there. But here is their hours that they've been walking, and here's how far they've been walking in miles. So we want to look at this data and see, is it really linear, or could it be exponential or quadratic? I don't want to plot this by hand, so I'm going to show you how to do it on the graphing calculator. So I'm going to show you how to do it step by step, but you got to follow along with me. So you got to have a graphing calculator, step 1, turn it on, and go to the stat key. So stat deals with data. You're going to go to stat edit. Okay. Stat edit. Everyone finds a stat key and go to edit. Stat, it's right under the word delete. Stat, right here. Did everyone go to stat edit? Stat is under the, it's like the middle top black button. Middle top, stat. Did you find it? And then I actually already have the data in from last class. You might be lucky and the data might already be in there. Stat and then hit enter for edit. So you already have the data in there. If you don't have the data in, you need to put the data in. Yours is already in there? Is yours already in there? Okay. What? So change it, you can clear the whole list if you want. So you to clear the whole list, you arrow up and hit clear enter. You hit clear enter and then you hit enter. Why does this in, oh yeah, this one. So then re-enter list 1 if you want to. Does everyone have the data already in there, or do you have to enter it yourself? Okay, I'm going to wait, because if you have to enter it yourself, that's okay. If you want to practice entering it yourself, why does that look like it's not already set of data? It's not. So you need to go arrow up, hit clear enter, and you're going to enter that in list 2. Go up, arrow up, hit clear enter. Make sure it's actually the set of data from the, this is actually the wrong data, isn't it? I'm going to enter my data. Hold on one second. clear, enter, clear, enter. So make sure it's the Jimmy Fund data. So 1, 2, 3, 4.5, and 5. 3.9, 7.5, 10.8, 16.5, and 18.5. Yep, Zoom 9, the choice should, oops, I have data in my Y equals menu. Y equals, clear this out, hold on, clear graph. You should get dots in a line. Okay, you have, just put your Y equals, clear out what's in there, okay, graph. Yeah, make sure the Y equals, clear out what's in there so that you only see your dots. No. That plot, oh, that's fine. That edit, let's turn there. Okay, Y equals, I'm gonna clear that out and hit Zoom 9. Second one equals step plot response to extract, edit. Maybe that's why. Let's just change the color to red would work probably. Okay, I think it's yellow and it's too faint for me to see. I think for something. Is that gonna be hot? Okay. You put it on your scan plot? Yes, it's on. There we go. There's dots. You got dots? Okay, let's get rid of this page and turn on line 2. What's it say 9? Yeah, great. You already have the equals page in there. Okay, this is where we're at. This is a lot, I know, but when you start doing this again and again, entering data, stat plot, looking at the data, it's the same steps on the calculator that we're going to do 10 or 12 times. What type of function is it, do you think? Yep, so it says graph a scatter plot of the data. We did that. Why is a linear function appropriate, do you think? Because it looks like a line, right? Yeah, looks linear. Yep, there we go. Okay, so is the rate of change positive or negative? Positive, it's going up, right? Positive. Given the situation, what should be the domain of the function? Do you know what domain means? Domain is allowable x values. What's our allowable time that would make sense? Can I have negative hours? I'm on question 5D. Given the situation, what should the domain of the function be and why? Every 2 hours, but can I have negative hours? So my x value has to be greater than or equal to 0. That's what it's getting at. Can the domain be all real numbers? I could plug anything in. I have to be walking for a positive amount of time. I can't walk for a negative amount of time. That's what it's getting at. We're starting to talk about some vocabulary words. Then it says, let's find an equation to model the situation. So you're going to use the button stat again, but you want to calculate something this time. So use the stat button again, go over to calculate at the top, see stat calculate. Here's where you have to be smarter than your calculator. You have to tell it what type of model would work best. Linear, exponential, quadratic. See how choice 4 is a linear reg? That stands for regression. Stats, you have to go back to stat again. Arrow over on the top of the menu. See how arrow over to calculate up top. And then choice 4, linear regression. And then let's just go down to calculate and have it calculate it for us. Calculate. Arrow over. It's on the top. Go stat, calculate. Stat, calculate. Stat, calculate. By arrow over. And then choice 4. And then you scroll down and calculate. Did you get an equation that looks like this? 4. Okay, let's see what we got to. I rounded it to 4 because it's a 6 that came after. I just rounded it to 2 decimal places, guys, but if you want to do more decimal places, 3.63 is not correctly rounded. So if you want to go 3.636, then you can do that. Okay. You guys get, so write down the linear equation. That's what it wants you to do on part the E or F.
Wait, what do I do when I go to count?
We're choosing number 4, linear regression. Okay, this is hard, guys. You haven't done this in a couple years or ever. Yep. There's your equation. Okay, so you're writing down your equation, sure. So here's my equation. You wrote it down on the line on choice D, right? See if you can use your equation to solve for part F. So the whole reason you want a regression equation is to do something. Part represents miles. So my equation was y equals 3.64x plus 0.17. That's my slope, that's my y-intercept of that line. They want to know how many hours is it going to take us to finish the marathon. It's going to be more than 18 and a half, right? At 5 hours, they'd only gone 18 and a half miles. More than 5 hours. In our equation, what is x and what is y? I'll help you do it. So up here in our chart, x was hours, y was miles, right? Hours, miles. So down here, x is hours, y is miles, right? You have to identify what's going on in your equation. I'm not saying this is easy. This is starting to be challenging, right? We're going to take an equation and do something with it. They want to know, how long will it take to go 26.2 miles? I plug 26.2 in for y in my equation, and you have to solve for x. See if you remember how to use your algebra skills to get x by itself. Are you with me on what I'm asking you? How do I get x by itself? Yes. So perfect. I want to get rid of this 0.17. So if I'm adding 0.17, what's the opposite of adding? Subtract 0.17 from both sides to get rid of it. All right. What? I don't know this in my head. I'm going to take 26.2 and subtract 0.17 and get 26.03. 26.03 equals 3.64x. Are you with me on that first step? If I'm multiplying by 3.64, what's the opposite of multiplying? Dividing both sides now by 3.64 to get my answer. I don't know this in my head, so I'm using my calculator. Yes. Nope, he's somewhere else now. I don't know. So x is 26.03 divided by 3.64, 7.2 hours. Does that seem reasonable looking at our chart? Yeah, after 7 hours about, I should finish the marathon. Did you know that there's a reason why it's important to know your pace? Has anyone ever run in maybe a half marathon or, yeah, you want to know your own pace because you want to try to beat it, but also when you line up, so this data for crickets was taken in Celsius. So I want us to first use some unit conversion and translate it to Fahrenheit just so it makes more sense to us. All right, so I'm going to help you translate it. We're going to translate it using this equation. There is a formula. The following equation can be used to convert Fahrenheit into Celsius. We want to solve this equation for F, for Fahrenheit. So let's just practice. How could I get F by itself? Well, I'm going to tell you, you're going to multiply by 9/5 because currently I'm multiplying by 5/9. So if you multiply 9/5 on both sides of this equation, the 5/9 goes away. We're trying to get f by itself. This is unit analysis. We'll look at it with slope-intercept form, but now my equation is 9/5 c equals f minus 32. Hey, this is an introduction, okay? So this is where you should be at the end of our linear unit. We're in an intro unit right now, so I'm doing it for you. But I hope that you know that a fraction multiplied by its reciprocal cancels out. If not, we're relearning that skill. Okay, so I'm trying to help you get this solved for f. What could I do next to get f by itself? Add 32 to the other side. 9/5 C plus 32 equals my Fahrenheit temperature. Maybe that you've never translated between Fahrenheit and Celsius before, so I'm just making you a more worldly mathematician and scientist. There is a conversion equation in a science textbook for this. All right, use your equation from part A that I just circled to fill in the Fahrenheit column up above. Let's do the first calculation together. I want to take on my calculator 9/5 times 31 degrees Celsius and add 32 to get my Fahrenheit. 9/5 Celsius plus 32. So let's just type it into our calculator together and see if we get the same number. 9 divided by 5 is how you type in 9/5. 9 divided by 5. Again, you guys made my lights, now you can't see on my calculator because my light is off. 9/5 times 31 degrees. And then what am I doing? Adding 32. You don't have to even do parentheses. You could just do 9 divided by 5 times 31 plus 32. 87.8 degrees Fahrenheit. That's a pretty hot day, isn't it? But 31 degrees Celsius didn't mean much to me. So 87.8 is the first data point. Let me show you a trick on your calculator to save you some time. Did you know that you can use the arrow up key to re-highlight the last equation? Hit enter, and you can just override the temperature. So what's my next temperature? 22. So did you know you can arrow up and then just override? So the second data point is 71.6 degrees Fahrenheit. So all you have to do on your calculator, I'll do it for you one more time. Arrow up to your equation, hit enter, and then just change your 22 to the next number. So the next number in my table is 24. So I just write 24. There you go, 75.2. This isn't too hard now, is it? You're overriding the equation with the next number. Need help? How do you back up to your where? Oh, go to second click. There you go. Just go to second click. And I'll arrow up one more time. Hit enter. And change 31 to the next number in your table. So go to 27. Hit 27. There you go. Use yourself. This is good to know how to use the calculator to override equations and just do the calculation. It's working? Yeah. Okay. If you want to try to answer your data, this is the temperature of this one, and this is the this one and this two. That's definitely this one and this two. If you remember how to do that step. So you might ask, why would I ever want to translate Celsius to Fahrenheit? Well, if the data is given in Celsius and it doesn't mean a whole lot to us in our English society, we might want to read it in Fahrenheit, right? So there is a reason to convert data. So what were the rest of them? 27. This came out to 80.6. Is that right? We are going to put this data in our stat edit in a minute. So we're going to redo our list 1 and our list 2 with this data. I just need to do my last 34, 93.2. And then what was 25? Oops. 77. Good question. Did everyone get Fahrenheit and cricket chirps? And if not at this point, feel free to copy from up here if it took you a while to calculate them, but we should have our Fahrenheit. No, we don't care about Celsius anymore. Well, these are not in numerical order. I did that on purpose. So 24 degrees Celsius is 75 degrees Fahrenheit. Okay, so now we want to well, section C, if you were to graph them, what would be independent and what would be dependent? This would be temperature is independent, right? And chirps is dependent. Our number of chirps depends on the temperature it is outside. We're going to try to see if is it colder, they chirp more, or if it's warmer, they chirp more. All right, cricket chirps. Use technology to view a scatter plot. All right, so you go to Stat Key, Edit. I wrote the steps up here. Stat Edit is first. Enter your data. You can just overwrite it. View your scatter plot, and then Stat Calculate to find your regression equation. So I'm typing in Fahrenheit in list 1, 87.8, 71.6. Oops. You should be able to hit zoom 9 after. Because you already have your scatter plot turned on from the last time. Cricket chirps is dependent on temperature, yes. So yes, cricket chirps goes in list 2 because it's the dependent variable. Yep, this should be Fahrenheit temperature. We're ignoring Celsius. We don't know what doesn't mean anything. Fahrenheit, cricket chirps. And then you should be able to hit zoom 9 to see the graph once it's all entered. You don't have to turn your scatter plot on because it already was turned on from the front page. Zoom 9. Which these are experimental pieces of data. So, experimental pieces of data are not perfect. Is that what yours looks like? Yeah. Okay. So, does it look linear, quadratic, or exponential? It doesn't really look like either of them. But if I was to draw in a line of best fit, does the data kind of follow a line of best fit? As it gets warmer, the cricket chirps do go up. I don't know what's going on here. Maybe I wrote the data wrong in the table. Maybe experimentally it doesn't correlate perfectly. But about as there is more temperature, the crickets chirp more frequently per second. So we're going to go with linear, but it doesn't look beautiful. I'll make sure that when I give you a model on an assessment, it's pretty clear what I'm going for. Linear, exponential, or quadratic. So let's record our equation. Do you remember how to do that? you go to stat calculate, right? Stat calculate. And it's the linear regression. We're working on linear today. Yep. And then scroll down to calculate. And there's your linear equation for cricket chirp. So let's record that together. Y equals 0.24x is your slope, minus 2.9 is your B value. You got 5 minutes. See if you can use your equation to answer E and F. And that's where we're going to end up starting